The probability of two events. Let's look at an unbiased coin that is tossed twice. Okay, A, list all the possible outcomes. All right, well, there aren't very many. We just flip a coin. So let's say the first one gets heads, and then we flip a second coin, and that can either be heads or tails. Let's just say it's heads. And so there's one possible outcome. You could flip heads, and then you could flip heads. And let's see what outcome number two. Let's say we flip heads for the first one, and now the second one, another option is it could be tails. So now we're sort of exhausted the heads first. So now let's say we flip in and we have tails first. Well, the next one that we flip could also be tails. You could get tails, tails, two in a row. Or you could get tails first, and then your second one could be heads. And that's it. Those are your possible outcomes. Heads, 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 tails, 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 or tails, heads. So there are four possible outcomes of flipping a coin twice. Okay, so what is the probability of obtaining two heads? Well, if we look at our list of the number of outcomes, there's 1, 2, 3, and 4. There's 4. So the probability of flipping two heads, all right, is going to be out of 4 possible outcomes, and there's only one that has heads, heads. So it's 1 out of 4. What is the probability of obtaining a head and a tail in any order? Okay, so probability of head and tail. So, again, there are still 4 possible outcomes. This one, this one, this one, this one. But now, heads or tails, you've got this outcome right here, or this outcome right here. You could have head, tail, or you could flip tail, head. So there are 2 ways of doing so. And then we can simplify 2 over 4 as 1 over 2. So the probability of getting a head and a tail is 1 out of 2. A red die and a blue die are rolled at the same time, and the scores are added together. What is the possibility of obtaining? And then we'll do these 3 different scenarios. So, first of all, I've already set up this little chart here. So we roll a red die, and of course you could have 1, 2, 3, 4, 5, or 6. And then you roll a blue die, and you can have the same outcome. So we need to fill this in with what's happening. So what's happening is we roll them, and then we add the scores together. It says so right here. So if we roll a red 1 and a blue 1, we add those together, we get 2. A red 2 and a blue 1, we get 3. A red 3 and a blue 1, we get 4. So we can pretty quickly fill out this chart with all of the outcomes that happen when we roll these die and then add them together. Okay, so if you roll a red 1 and a blue 5, you get 6. A red 2 and a blue 5, you get 7. And so on. So you can fill out this chart all the way to the end. Now, we can count them all up, or just, we know right away there's 6 this way and 6 this way. So if we multiply it together, there are 36 possible outcomes from this list. 36, okay? Let's answer A. What is the possibility of obtaining a score of 5? Okay, so what you have to do here is look and find the 5s. There's one here, 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 and here. Okay, there are 4 ways of getting a 5. So the probability of rolling a 5, okay, there are 4 ways of getting it out of, we already said the total amount here, the total possible outcomes is 36. And we can simplify 4 to 36 to 1 out of 9. So the possibility of scoring a 5 is 1 out of 9. Okay, how do we get a score greater than 3? Or what is the possibility of obtaining a score greater than 3? So 3 doesn't count, 2 doesn't count, everything above that counts. So that's all of these values. So it's a lot easier for us to just not include the ones that don't count. I.e. 2 doesn't work and both 3s don't work. So 3 of them don't work, all the rest do. So 36 minus 3 is 33. So the possibility of a score greater than 3, there are 33 ways we can get that score out of 36. And we can simplify that fraction, divide each by 3, so you get 11 over 12. What is the possibility of obtaining an even number score? All right, so we'll probably have to go through here and count these all. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of those scores. So the probability of it being even is 18 of those 36 scores, and that is 1 over 2. All right, moving on. A card is taken at random from a pack of 52 playing cards and then replaced. A second card is then drawn from the pack. Determine these probabilities. Okay, so it's important that it's replaced. So we always have that pack of 52 cards. So we're going to do one thing and then we're going to figure out another. So for this question, let's make a tree diagram for what is happening first. Both are diamonds. Okay, so what are the probability that both are diamonds? Actually, all these questions are diamonds, which makes it a lot easier for us. So first we draw our first card. All right, so here we are. This is going to be drawing our first card. So we are either going to get the diamond. I'm just using this symbol because I don't want to write it out. And as you can see here, I've got these diamonds as well. So diamonds or not diamond. And I will use the bar above to symbol. That means not diamond. All right, so how many diamonds are there in a pack? Well, one of the suits is diamonds. That means one of the 4 suits is diamonds. So this represents our first card. So our draw, the odds of getting a diamond are 1 out of 4. The odds of not getting a diamond are therefore 3 out of 4. Right? 3 of the suits are not diamonds. 1 of the suit is diamonds. Now we're going to we replace it and then we draw again. Okay, so again, we either have diamond, not diamond. And then on this one, we have diamond, not diamond. This represents our second card draw. So to have diamonds, 1 out of 4, not diamonds, 3 out of 4. To have diamonds, 1 out of 4, not diamonds, 3 out of 4. So what do we have here? We have illustrated how we can look at getting a whole bunch of different scenarios with diamonds. So here, we can either draw a card and draw a card, and both of them are diamonds. So the probability for that is 1/4 and 1/4. So that's 1/4 times 1/4, and that gives us 1 over 16. We could draw a diamond, and then we could draw not a diamond. And the odds of that are 1/4 times 3/4. That gives us 3 out of 16. We could draw not diamond and then diamond. Okay, so that's 3 out of 4 times 1 over 4, which is also 3 over 16. Or we could draw not diamond, not diamond. So that's 3 over 4 times 3 over 4. So 9 over 16. So you see, most of the times we'll draw not diamond 2 cards in a row. So we can use this information to now answer these questions. Okay, so what are the odds that both are diamonds? Both are diamonds up here, and the probability is 1 out of 16. So the probability is of both diamonds, I don't really need to write that, I'll just write the answer, is 1 out of 16. The probability that at least one is a diamond. Okay, at least one is a diamond. So here we'll have at least 1 diamond. Here we'll have at least 1 diamond. Here we'll have at least 1 diamond. And only this one doesn't have a diamond. So only the last row doesn't have a diamond. All the rest do. So we can add these up. 1/16 plus 3/16 plus 3/16, and that adds up to 7/16. So the probability of having at least 1 diamond is 7/16. Exactly 1 is a diamond. Okay, that means only 1, and that is either here or here. Here we would have 2, and here we'd have none. So it's this column, it's this row and this row. So we add these together, and that will be 6/16. which simplifies to 3/8. Probability of exactly one diamond, 3/8. The probability that neither is a diamond, we talked about that first actually, it's right down here. Okay, so it's not diamond, that gives us this value right here, which is 9/16.